Welcome to dNAxt. We are discussing class A subnetting, and in class A in this video we'll be discussing /12. /12 signifies that there are 12 bits assigned to your network. So when 12 bits are assigned to the network out of 32 bits, remaining 20 bits are of the host. Now out of the 12 network bits that we have for our network, 8 are the default network bits, because for class A default CIDR value is /8. So 8 belongs to major network, and we have borrowed 4 more bits which are highlighted by green color. These are the 4 bits that we have borrowed for subnetting in class A. So 4 bits are sub-network bits. 4 bits are our sub-network bits, and if we calculate the value of it, 128 plus 64 plus 32 and plus 16, that comes out as 240. So subnet mask will be 255.240.0.0. Now let's calculate how many subnetworks we will get when we borrow 4 bits. We get 2 to the power 4. That means 16 subnetworks we are going to get over here. Okay. How many hosts per subnetwork? That is, the formula is 2 to the power y minus 2, where y is the number of host bit, and just now we discussed we have 20 host bits. 8 plus 8, 16, 17, 18, 19, 20, or 32 minus 12, 20. So 2 to the power 20 minus 2, and 2 to the power 20 is 10 lakh 48,576. These many IP addresses you will get in each subnetwork, and the valid host you will get by subtracting the number 2, because one is the network ID, another is the broadcast ID in each subnetwork. So valid host that you can accommodate in your each subnetwork will be 10,48,574. What will be the increment in this case? So that is 256 minus subnet weight value, which is 240 over here. So the increment of 16 will be there in /12. So let's write down those 16 IP addresses, and let's discuss about them one by one. So the first valid IP address that we will get is 10.10.0.0, right? Sorry, 10.0.0.0. Increment is of 16 in the second octet, as we have borrowed the bit in the second octet. So 10.16.0.0, 10.32.0.0, 10.48.0.0, 64.0.0, 80.0.0, 96, sorry, yes, 96.0.0, 112.0.0, then 128.0.0. फिर से when we add 16 to this, we will get 144.0.0. Then again 16, so 160.0.0, 176.0.0, then again 16, that will be 192.0.0, then again 16, when you add over here you will get 208.0.0. Then again when you add 16 over here, you will get 224.0.0, and then 240.0.0. Again, when you add 16 over here, you will get 256, which is not valid IP address. So these many IP addresses you will get in each of your these are the network ID of each of your subnetwork. Now let's write down their broadcast ID as we have discussed. It will be 10 dot previous IP previous number 15.255.255 as third and fourth octet are purely host octet. Here it will be 10.31.255.255. For this it will be 10.47.255.255. For next, it will be 10.63.255.255. For 10.64.0.0, it will be 10.79.255.255 broadcast ID. We are writing broadcast ID over here. These are the network ID of all of your 16 sub-networks. These are the broadcast IDs. Here it will be 10.79.255.255. Here it will be 10.95.255.255. For this network, broadcast ID will be 10.111.255.255. For this, it will be 10.127.255.255. First valid host over here will be 10.112.0.1 and last valid host will be 10.127.255.254. Then here it will be 10.143.0.0. Sorry, 10.143.255.255 will be the broadcast ID. Last valid host will be 10.143.255.254. Okay. Here I'll write it down so that it will be easy. 243.255.255 will be the broadcast ID and 10.143.255.254 will be the last valid host. For the last subnetwork 10.255.255.255 will be the broadcast ID and 10.255.255.254 will be the last valid host. First valid host will be 10.240.0.1. So this is all about this is not /20, this is /12. Okay, this is /12. There is a typo error over here. So this is /12. So these 16 sub networks we will get in /12. So stay tuned with dNAxt. Thank you.